Let's talk about branching. Branching is a way of controlling the execution order of your program. We're going to specifically in this topic talk about the if-then-else branching statement. All right, so we're going to go back to the festival here in my town. We're going to again phrase it as I'll go to the kite festival if it's sunny, it's not raining, and I'm not working. So let's look at the way this is laid out. If each of these conditionals is true, so therefore all of these are true, then the if is true, then I'll go to the kite festival. We can express that as if the conditions are true, then I'll go to the kite festival. Let's visually map this out. So here is a decision flowchart. I introduced you to flowcharts earlier. If it's sunny, so therefore we ask the question, is it sunny? If yes, then we'll move to the next conditional. Is it raining? If no, we'll move to the next conditional. Am I working? Well, I am right now, but will I be for the weekend? If the answer is no, then I'll go to the kite festival. All right, but there's other paths that this can take, isn't there? So here are the paths to get to not going to the kite festival. Is it sunny? No. You can see that we just come right out of that conditional and straight down into we're not going to the festival. We do not go through the other two conditionals. There's no reason to. Next, we're going to check, is it raining? Oh, sorry, it's raining, so therefore I'm not going to go. Am I working? Well, I probably am. So therefore, I'm not going to go. This is an if statement. These are my conditionals. I'm either going to go or I'm not. Therefore, if these conditionals are not true, or in their true state as how I have them stated, then we're just not going to go. So let's take a look at an actual structure in code. Here's an if-then statement. I have the parentheses in the if part of the statement. It's because everything within the if has to compute to give the if a true value. If that everything within there equates to a true, then we'll go and execute the then portion of the if. And that makes sense. That's what you do in your natural way that you speak. I'll do this if. And it's just inferred that, okay, well, I don't go and do the then because I never got there because the if wasn't true. All right, well, let's just lay this out. I've got some ands in there. Is it sunny? And is it not raining? And I'm not working. So let's see how these equate out. Here we go. We're going to compute these. So is it sunny? Yes, it's true. And it's not raining. Yep. Okay. That's true also. So I've got true and true. What does that equate to? Remember your AND gate from SC100. What does that equate to? True and true gives you a true. Now I've got true and am I working? Well, let's just say I'm not going to work. I'm going to go ahead and take a day off so that I can go to the beach. So therefore, that is set to a true state. So now I've got true and true again. That equates to true. Now the entire if is true. Therefore, I can execute the then. I'm going to go to the kite festival. Yippee! This is how it breaks down. If, and then the conditions that has to compute to true, then do something. So the conditions need to be true to move on to the then part of the expression. If all the conditions evaluate to true, then we're going to do whatever is in the then part of the expression. Now, there are different ways that you can combine conditions. You can have an or, you can have an and, you can have an XOR, you can put a not in there. The key is, as the expression is put together, you run through that and that the entire if expression equates to true. So what if the conditions are not set? What else can I do? All right, well, here's an else flowchart. Ready? We've got our sunny again. Is it sunny? Yes. Is it raining? Nope. Am I working? Let's just say no. All right, I'm going to go to the festival. What's the else part of this? Is it sunny? No. I'm going to do something else. So therefore, there's an else. See that? Or it might be raining. All right, well, I'll go to the movies. Well, I don't think I'd go to the movies if I'm working, but you kind of get the point here, right? Let's look at this. If the conditions, again, for this time, if they equate to false, then I'll do the else. So let's look at this. If the conditions are true, then do something. Otherwise, which is what else means. So if this is false, I'm not going to do this part. I'm going to come down here and I'm going to do the else part. That makes sense even in your natural language. Let's look at one more. All right, so let's say I'd like to have some more options to this. So therefore, I need an else if flowchart. Well, let's look at what that might be. All right, this is what we had before. Nothing's changed here. I'm going to go ahead and bring raining over. So yes, it's raining, or it's not sunny. What else might I want to do? Okay. Is there a movie at the cinema that I want to see? Well, yes, there is. Good. Let's go to the movies. That's my else if. All right, well, I still have an else in there. You see that? No, there's no movie that I want to see, or I'm working. So therefore, I'm going to stay home. What does this look like? Looks like this. This part is the same, so we've got the conditions. So we're going to go through and we're going to say, okay, if the conditions are false, I'll skip down here to the next one. Else if, are these conditions true? Why, yes, they are. So therefore, I'll do that instead. Or no, they're not. So then it will jump down here to the else, and it's going to do this one as a default. Does that make sense to you? Stay right here. Make sure it makes sense. Don't move on until it does. You can go backwards and listen to me again and walk through it. Make sure you get this. All right, so what else is happening here? It's determining the control path of the logic, the sequence of how the logic is executed, how the language itself orders the execution of the software. It changes that based upon the conditions. That's why it's called branching. Instead of just going down the line with software, starting at the top, running through each of the expressions line by line by line, we have a way of changing the control execution and say, nope, we're going to stop here and we're going to consider if this, then that, or go do something else. So let's take a look at it in other languages. So this is the if-then in languages. Ready? This is C. Now notice I just put together some variable names that will help us out. I've got weather is sunny and weather is raining, and I put it as a not, and is working is also a not. So therefore, this would equate, if it's not raining, I'm not working, and it is sunny, that would be true, and I'm going to go to the festival. And I've got movie is playing, and you can see how this looks. This is C language. It looks a lot like PHP, doesn't it? Here's PHP. Notice that C has print F. It still has the else if, and notice there's no $sign as we have in PHP before the variable. Otherwise, it looks pretty similar, doesn't it? How about Python? Here's Python. Notice that we don't have parentheses. We don't have the curly braces. Instead, we have a colon. Notice the else if is different. We're using prints, and the exclamation point is replaced by the actual word not. But however, look at the structure. It's the same, isn't it? Therefore, you can move from C to PHP to Python and know how to be able to code an if, or else statement. So what are the takeaways? Conditional control statements determine the flow of the program. We have the if then, we have the if else, we have the if else if, and else. Combination of the conditionals must evaluate to true. So the entire if has to evaluate to true for the if or the else if to be true. And you saw that. We just went through that.